Hey guys, welcome back to Genius Learning. All right, I just want to review some components, some fundamental things you need to know in order to break things down into components. Okay, so I want to start off here, right? This coordinate system. Let's say I have a force. Let's do it in a different color. All right, let's just say I have a force, right? It's being pulled here. I'm going to label it F1, right? And it's at some angle. So right now it doesn't matter. We want to express this force. Let's say somebody's pulling it. And we want to express this force right here into an X component and a Y component. How much is it being pulled in the X? How much is it being pulled in the Y? Right, so we need to break it down. So to do that, we're gonna, draw this dotted line here, draw this dotted line here. You can even put maybe arrows. So an arrow this way and an arrow up. So our goal is to get rid of this green one, and now we're gonna represent it as two, which is gonna be this one and this one. This one down here is gonna be Fx, right, because it's in the X direction. And this one up here is gonna be Fy, because it's in the Y direction. Okay, so, all right, so we're gonna do trig, okay, so opposite. We're gonna find this one first. We're gonna do opposite, which is this side, over hypotenuse, which is here. Okay, I'm just gonna do a quick review on some trig, because I know many of us forgot. So let's do here, we got, oh, that's ugly. Ugly. Let's go with one of these. All right, so we got, let's see. We know sine is opposite over hypotenuse, and we know cosine is adjacent over hypotenuse, right? And so if I move the hypotenuse over here, I'm gonna get hypotenuse, right, times cosine theta, and that's gonna equal to adjacent. And if I move the hypotenuse up here, I'm gonna get hypotenuse sine theta is equal to opposite. So I want these two representations, right, for the same type of thing here. If I have something like that, where I have, let's say F1, F1, where F1 will be our hypotenuse. Let's just write it how we have it here. So, perfect. This is gonna be our hypotenuse, right? And here is gonna be our opposite side, because it's opposite to the angle. So the side opposite to the angle, and then the side adjacent to the angle, right here. And this is the hypotenuse, okay, which is equal to F1. So now, if I want to represent this side, this opposite side, right, I have it right here. I put hypotenuse times sine. So this is hypotenuse times sine theta. And if I want to represent the adjacent side, right, I got to write hypotenuse times cosine theta. Okay, let's put these in parentheses. Perfect. So just how I want to represent my Fy, which is this side right here, that's equal to my opposite side. And so here I'm going to write hypotenuse times sine of theta. Here I'm going to write hypotenuse, which is F1. Okay, so I'm going to write F1. That's the hypotenuse. And then I'm going to write sine theta, right? So sine theta, that's done. Now I want to represent the adjacent side, which is down here, which is Fx. Okay, and that's going to be hypotenuse, which is F1. Right, that's the hypotenuse. And then cosine of that angle. Perfect. So now we can even do this. We can even, let me see, put one of these little squiggly lines in it. And now that means that this vector here, this force 1, does not exist. We just broke it into two components. We explained it better, right? We explained the direction of force in the X and the direction of force in the Y. So this one here no longer exists. Now we have taken this and wrote it into two different pieces. Okay, now I'm going to show one more example here. Okay, and let's see, I'm going to do this, and I'm going to do the angle in here on this side. Okay, so the same thing, we want to represent this F1. I'll call this one F2. Right, so we want to represent this F2. And also, just to keep in mind, this theta will be F1 will be theta 1, just because we want to distinguish this angle in here is different from the one up here. I'm not doing like a similar triangle. This one could be an angle completely different. So this is theta 2. So this one could be like, 23 degrees up here. And this could be like 29 or, 45, I don't know. They're different. And so we're going to break this force component into two parts, just like we did here, except now the dotted line goes across the theta, right? I do it here, goes across the theta, and now I'm gonna do an arrow going up like this, and one going sideways like that. So I'm meeting the tip. I'm going up, right, and then sideways. It's like vector addition. Okay, so this side right here is the Y. So we're gonna do Fy, right? Because I don't want to write vector sign. All right, the Y is up, so this one is Y, and up here is Fx. Okay. So now, this is where a lot of people get messed up and get tricks played, but I think it's pretty simple. And so here, right, on this side, we want to represent if we want to draw a little triangle to show here, right, we got this theta, and this is opposite now. This is hypotenuse, right, this one right here, and this is adjacent. Okay, so now we want to represent the opposite side. So what do we got to do? We know that the opposite, right, is hypotenuse times sine. Perfect. This is the opposite side. And so now we got to represent it with hypotenuse times sine. Hypotenuse is F2 and times sine. Okay? And then we want this side over here. We could see by this triangle that's the adjacent. And the adjacent side is hypotenuse times cosine. So I'm going to do hypotenuse, which is F2, times cosine. Okay? Now notice the difference here. This one here is like your standard. Your Y goes with sine, your X goes with cosine. You never want to memorize that, because look what happened here in this situation. You got your X with sine and Y with cosine. And that's because the angle reference that we used was different. Yeah, we can use this angle. Let's say we know this is 30 degrees up here. We're gonna know that this one's 60, right? Because of the 90-degree angle, we're gonna know this one's 60. And so we can use this 60 and break it up again and get it this way. But if we just use this angle here, or if you're asked just to use this angle, then you need to understand how to do the triangle. It's no different, it's just a little bit confusing. Don't memorize X goes with cosine, Y goes with sine. They could be intermatched because of the angle reference. Okay, so now in the next video, I want to show how to break down these three force components. Okay, and they have different angles, they have different masses attached to them, and then we want to find what's going to be the resultant force, right? And what angle. So what angle and how much weight do I have to put here to balance all these three forces out, let's say this is like a small person, a big person, and then like, you know, someone's uncle or something, just pulling on a rope. Everybody's putting on a rope. Who do I have to put here? What big guy or whatever do I have to put here and at one angle from the zero, so that way nobody moves. Everybody's just staying still. And that's the objective, right? So the next video, I want to show that. Practice these, write them down. Try to understand your trick very well, because the next couple examples is going to be pretty heavy with it, okay? I hope that helped. Thank you, guys.